Hey, what's up, guys? Back with day 13 here. Today we're going to take a look at a little bit of notation. We're also going to take a look at derivatives to memorize. And a big one is the product rule of derivatives. First off, with notation here, if I have f of x and I want to do the derivative, what notation do I use to show the derivative of f of x? Well, that we already know. We've been using it a lot. That's f prime of x. Okay. So if we have an f of x equation, we use, to symbolize the derivative, we use f prime of x. If we have y equals something, we have an equation with y. Right? It doesn't make sense to use f prime when we have y equals, right? So let's say, just for example, we use y equals 3x squared. If we do the derivative, our notation is dy dx equals 6x. So we use dy dx as well. You remember from your calculators that when you do your derivatives through the graphs on your calculators, the button was dy dx. So it's the same thing, it's just a different notation for that derivative. Lastly, if I want to do the derivative of an expression in terms of x, I might say something like this. And this d dx just means derivative. If it's not written in equation form, the derivative of 6x to the fourth equals 24x cubed. So that d dx is just showing that I'm doing the derivative of that expression, 6x to the fourth, and I get 24x cubed. So anytime we see d dx, dy dx, f prime or g prime or h prime of x, we know those are all meaning derivatives. Okay, there are a few derivatives that we just need to memorize. I'm just going to list those quickly. The sooner you can commit these to memory, the better, the easier everything will be for these next few videos. All right, number one is we're going to learn some trig derivatives. Our first derivative is the derivative of sine of x. The derivative of sine of x is always equal to cos of x. Okay. We should also know the derivative of cosine of x. Now, unfortunately, it's not just sine of x. It's close to that. It's actually negative sine x. Lots of students tend to get numbers 1 and 2 mixed up. So commit them to memory so you never mix them up. Derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The other one that's important to memorize is the derivative of tangent of x. The derivative of tangent of x is secant squared x. As a reminder about secant squared x, that's the same as 1 over cosine squared x. We know from our reciprocal trig that secant x is the same as 1 over cosine x. So secant squared x is the same as 1 over cosine squared x. Okay? The next one is natural log. The derivative of the natural log of x is always equal to 1 over x. Two more to memorize. The derivative of e to the x interestingly enough, always comes out e to the x. And I'll look at that in the next one. And our last one is the derivative of a to the x. A here is just any constant. The derivative of a to the x is a to the x times the natural log of a. Now, if we apply that to number 5 real quick, e is a constant, right? It's a constant numerical value, approximately 2.7. If we think about applying rule 6 to rule 5, the derivative of e to the x should be e to the x ln e. Well, ln e is always equal to 1, so it's just e to the x times 1, which is e to the x. Okay, so we don't have to worry about that. Okay, next big rule here is called the product rule. Now, if we have functions that are tied together with addition or subtraction, we just go through and do the derivative of each one like we've been doing. But with the product rule, if we're doing the derivative of a function times another function, it's not that easy, or it's not that simple. There's a rule that goes along with it. Okay, take a look here. Our generals, it's important to know the general rule and then how to apply it. Here's the general rule. If we do the derivative of a function f of x times another function g of x, this will always simplify to the derivative of the first times the second plus the first times the derivative of the second. Notice each function gets the derivative done to it once, and each function gets left alone once. So again, the derivative of the first times the second plus the first times the derivative of the second. Okay. In words, derivative of first times second plus first times derivative of second. Okay, let's apply this to a function that is a product of two other functions. Okay, I'll do two examples here. Okay, so let's say f of x is 6x cubed sine x. I'm going to ask you to find f prime of x. F prime of x then will be, well again, this is my first term, and then the multiplication of the second term. So in my formula, this is like f, and this is like g. And you don't have to label them that way. Okay? But it'll help us kind of follow the pattern here. So here's what I do. I take the derivative of the first term. Well, the derivative of 6x cubed is 18x squared. That's the derivative of the first, and I multiply it by the second. Notice I'm not doing the derivative of the second. It's just simply g of x. G of x is sine x. Derivative of the first times the second. Plus my first term, which is 6x cubed, times g prime, times the derivative of the second. The derivative of sine x, we know, is cosine x. And there I have it. After you apply the product rule, take a look and see if there's any simplification. Right here, I don't see any simplification, so I'm just going to leave it as f prime of x equals 18x squared sine x plus 6x cubed cosine x. Let's do one more example. So y equals tangent x times natural log x. I'm going to ask you to find dy dx. Again, dy dx we know is the notation for the derivative of the function y with respect to x. To find dy dx, well, I'll say dy dx equals this. Well, I'm going to do the derivative of the first function, which is secant squared x. It's one of the ones to memorize. That's the derivative of the first times the second, ln x, plus the first, which is tan x, times the derivative of the second, which is 1 over x. Cleaning this up just a little bit, I might say dy dx equals secant squared x ln x plus tan of x over x. And there we have it. So product rule is just derivative of the first times the second plus the first times the derivative of the second. That's it for this video, and I'll see you guys later. Bye.